Hello everyone. This video is for our critical thinking class as we are now in week 7 of the course learning about deductive reasoning. So let me share a screen with you and take a look at the announcement for the week. Last week we learned about inductive arguments which seek to determine the strength or weakness of claims. This week we are focusing on deductive arguments which seek to determine truth or falsehood of claims. Our work for the week is the deductive argument assignment, which is due Friday the 21st. Please note that this week has a Friday deadline instead of a Sunday one. What I want to do in this video, I think I'll keep this one pretty short. I probably say that every time and then still go 12 minutes or something. But I wanted to just briefly give you guys kind of go through this Prezi that I shared together so that we can talk about or think about what deductive arguments and deductive reasoning is all about. So let's jump right in. Deductive versus inductive arguments. As I said, the main difference is that with a deductive argument, we are trying to move from general premises to a more specific conclusion, whereas inductive arguments move from specific premises, statements about a thing, facts about a thing, to a general conclusion. And deductive arguments are true or false. We can judge the conclusion based on truth or falsehood, whereas inductive arguments, we can only judge the conclusion based on the strength or weakness of it. Both argument styles operate in much the same manner otherwise. So let me look at a deductive example with you. All birds have feathers. That is my first premise. Most deductive arguments, I should say to begin with, or at least for our purposes, when we're thinking of deductive arguments, we often think of them in terms of premise leading to premise 2, leading to maybe premise 3 or 4 or 5, and then leading it to a conclusion. With the idea being that if all of the premises are true, meaning they are sound, the argument is sound, these are true premises, and the premises logically relate to one another in a logical order, that being validity. So if the argument is sound, meaning the premises are true, and the argument is valid, meaning that the premises logically connect to one another, then the conclusion has to be true. And that's sort of the big deal with deductive arguments. So we have our first premise here, all birds have feathers. We have a second premise, a blue jay is a type of bird. Notice that I used the word all at the beginning of this premise to sort of set up the idea. It's not some birds, it's a 100% of birds have feathers, right? A blue jay is a type of bird, therefore a blue jay has feathers. The idea is if this premise is true, if premise 1, that all birds have feathers is true, and premise 2, that a blue jay is a type of bird, then the conclusion is necessitated by the argument. A blue jay has to have feathers if it is a type of bird and all birds have feathers. So remember, we are working with true or false statements rather than strong or weak. If the premises are true and logically related, if I could speak today, then the conclusion has to be true. Blue jays have feathers. We can accept as a true statement because we also can accept as a statement that birds have feathers and that blue jays are a bird. Let's look a little bit deeper into validity. Validity refers to the logical form of the argument. If the conclusion must, meaning necessarily so, necessitates. If the conclusion follows from the given premises, then the argument is valid. Soundness refers to the truth of an argument. An argument is only sound if its form is valid and its premises are true. And if the form is not valid, the argument is not sound. If the premises are not true, the argument is not sound. So here's an unsound example. Premise 1, Jake is a boy. We can accept that as a true statement. Premise 2, boys love eating asparagus. I don't think we can accept that as a true statement. Conclusion, Jake loves eating asparagus. This would be, so we could consider this valid in terms of if this was true, and if premise 1 was true and premise 2 is true, then the conclusion is true. So if Jake is a boy and all boys love eating asparagus, then it's a true argument. It's a proper deductive argument. But the second premise is likely false. Not all boys love eating asparagus. Unsound example number 2, all nurses wear medical scrubs. We can go ahead and accept that as a true statement. Stephanie is a nurse. Sure, let's go ahead and accept that as a true statement. Conclusion, Stephanie loves wearing medical scrubs. This is not a valid conclusion because it doesn't follow from the premises. It may be true that all nurses wear medical scrubs. It may be true that Stephanie is a nurse, but nothing about her being a nurse and wearing medical scrubs means she loves wearing medical scrubs. It would work if it said all nurses love to wear medical scrubs and we accepted that as true. I highlight this for a reason. The wording in these arguments is important. Words like all or some or love, these words can change the entire meaning of an argument. So be careful as you're constructing your own that you are thinking through the specific wording. So essentially, you should now know enough just with that simple introduction to complete this week's assignment. Part 1 is just asking you to finish the logical conclusions to the provided premises. For example, Mr. Colby needs coffee to survive his day and be a happy teacher. We can accept this as a true statement. Premise 2, Mr. Colby did not have time to make coffee this morning before leaving to teach. True, unfortunately. Conclusion, you would have to come up with the answer. If premise 1 was true and premise 2 is true and they relate, the conclusion would be Mr. Colby will not survive his day, nor will he be a happy teacher. That's pretty much it. So the second part of the assignment is just asking you to construct your own arguments using premises and conclusions that are logically connecting in a valid and sound way, meaning the premises should be true and the conclusions should logically follow, thus the arguments will be valid and sound. I highly recommend you keep it simple and just have fun with this. Where students have had issues in the past is that they try to greatly overcomplicate their arguments and they lose validity or soundness somewhere in that process. I do want to take a moment to look a little deeper into how deductive arguments work and how different types of deductive arguments and sort of a glimpse at formal logic. So don't feel like you have to follow this in your assignment, but I did want to give you a little bit of a deeper understanding. So philosophers and logicians sometimes deal with the arbitrary nature of language by taking complex arguments and assigning variables to the premises. They are then able to treat the argument like an equation from algebra and judge its validity, its soundness, and ultimately its truth. So mathematicians use X's and Y's, philosophers and logicians use P's and Q's for variables. But the idea is that you could take an argument, you could break down its individual premises, assign a variable to them, and then ignore the actual wording that's being said and just see if formally the argument makes sense in terms of its variables fitting to a proper argument form. So let's take a look at this example. If I drink coffee, I will be happy. I drank coffee. The conclusion statement then would be, therefore I am happy. The idea is to assign variables to the individual phrases. So I drink coffee, we will let that be represented by the variable P. I will be happy can be represented by the variable Q. I drank coffee is the same as I drink coffee, so we can get rid of the rest of the words, and our argument breaks down to this. If P occurs, Q occurs, P did occur, so Q occurred. Or simply, if P, then Q, P, therefore Q. This is an argument type called modus ponens. Modus ponens is Latin. It means the way that affirms by affirming. And it's simply if P occurs, Q occurs, P did occur, so Q occurred. It's simple cause and effect. If I get enough sleep, I won't be tired. I got enough sleep, so I'm not tired. P, therefore Q, P, so Q. In formal logic, if you were so inclined to study formal logic, they use symbols to represent the entire thing and get rid of all of the language, because even like occurs is a problematic word. What is it? how does that work in terms of being tired or happy or having coffee or whatever? So they try to eliminate words that can be semantics or judged in a weird way and break it down to just the letters, the variables themselves. So it would look something like this: P, therefore Q, P, therefore Q. Their second version, a common version of this type of argument, is called modus tollens. Modus tollens is an argument, Latin, that means the way that denies by denying. And it works like this: if P occurs, Q will occur. Q did not occur, therefore P did not occur. You can flip this premise and this conclusion. It could be if P occurs, Q will occur. P did not occur, therefore Q did not occur. It works either way. It's the negation of the cause and effect. If I get enough sleep, I won't be tired. If I get enough sleep, P, I won't be tired, Q. I am still tired, so not Q. Q didn't occur. I'm still tired, therefore P didn't occur. I didn't get enough sleep. If P then Q, not Q, therefore not P. Or if P then Q, not P, therefore not Q. So we can break it down to formal logic. It looks like this: P, therefore Q, not Q, therefore not P. Here's my example. If I get some sleep, I will be ready for work. If I get some sleep, P, I will be ready for work, Q. I am not ready for work, not Q, therefore not P. I didn't get any sleep. The third one that we want to look at is the hypothetical syllogism. Hypothetical syllogism works like the transitive property in algebra. If you can remember back to that, the transitive property simply states that if x is y and y is z, then x has to be z. If x equals y and y equals z, x has to equal z. The way it works for logical theory, or formal logic, is if P occurs, then Q occurs. And if Q occurs, then R occurs. P occurred, therefore R occurred. It's the same thing as a cause and effect. You are just adding one additional step into the argument. So for example, if I put gas in my car, P, I can get to work, Q. If I can get to work, Q, I will teach all day, R. Therefore, if I put gas in my car, P, I will teach all day, R. So it's almost like it rolls a chain of events, a chain of cause and effect. The last one to think about is the disjunctive syllogism. This is the last of the four major argument forms, and it works a little bit different than the other ones, only in the sense that it is an either or statement. P can occur or Q can occur, and in formal logic they represent or with this little V thing. P can occur or Q can occur. One of them didn't occur, therefore the other one did, or one of them did occur, therefore the other one didn't. So the argument, for example, I will either have cereal or eggs. Cereal being P, eggs being Q. If I did not have cereal, I necessarily had eggs. If I did have cereal, I necessarily did not have eggs. If I had eggs, I did not have cereal. Make sense? So you can kind of switch the order around a little bit as long as you establish that initial, there's two choices, P or Q. One of them did or didn't happen, therefore the other one did or didn't happen. That's really it. I would just invite you to not overcomplicate it. Like I said before, it gets confusing when you try to make it too elaborate. And also just be real careful of your wording. A word like all or sometimes or probably can really complicate these arguments and make them not valid or not sound. Please remember that assignment is due Friday night, not Sunday night, Friday night, the 21st. If you have any questions, please email me, text me, give me a call, get in touch with me one way or the other, and I would be happy to help you. That's it. Hope you guys have a great week.